All right, everyone, welcome to our first lesson for geometry. This unit focuses on the foundations of geometry, so building a basic understanding of some terms and vocabulary that we'll be using for the rest of this semester and the spring semester. So let's begin with understanding some of our most basic figures in geometry, and these are our undefined terms. And I would encourage you guys to download this PDF from Schoology into Notability, and you can follow along with these guided notes there, or you can print this out and handwrite these notes and follow as we go along. We call these undefined terms because they cannot be defined using other figures in geometry. Instead, we use some words or terms that you're probably familiar with and already have a definition. So these undefined terms are points, lines, and planes. And they're the building blocks of geometry, and you're going to see how we're going to define these here in a sec. So a point just names a location. And has no size. So the size of the dot does not determine how big that location is or how large that point is. A point just simply names a location. Okay, and you can see three examples here. The way we name a point is just the letter above that dot. Examples of points in everyday life, well, we have push pins. You could put a push pin on a map that denotes a location or names a location. Another one you're probably more familiar with is just dropping a pin on maps. And you guys do that on your phone all the time. If you want to drop a pin to show someone your location, it's a perfect example of a point that denotes or names a location. A line is a straight path that extends in opposite directions without end. Right, you're going to see lines everywhere in geometry this year. You probably saw a lot of lines in algebra last year. The way we name a line is any 2 points. Just make a little note of that here. Any 2 points on that line, or the letter above or below that line. So we could name this line AB with a line symbol above. We could name this line BA, order doesn't matter, or we could write out and name this line M. That's that letter that's above or below or right next to that line. Okay. An example, if you were in my classroom today, you would see above the whiteboard, or maybe you remember this from last year, number lines. You guys have seen number lines before, where all those points on that line are just numbers representing a distance from each other. We'll be using those a lot this year. A plane is a two-dimensional, 2D standing for two-dimensional flat surface that extends in all directions, not just opposite directions, but all directions without end. And this one's a little harder to imagine. It's a little harder to visualize because most of the planes we have, they stop. They don't continue without end. But some examples you could just use, imagine a piece of paper extending in all directions without end. Or you could imagine a wall in your room, or a classroom wall is a plane. I know those end, but you could just imagine that plane extending in all directions without end. The way we name a plane is any 3 non-collinear points. What is collinear? You're going to find out in just a sec. You can imagine what that definition might be, seeing co and line in it, but we'll define that in just a sec. So we could name this plane ABC, or we could name it any 3 points. It doesn't matter what the order is, C, A, B, or that letter in the corner, plane M. Remember, M is not a point because it doesn't have a dot next to that letter naming a location. Instead, it's just a letter in the corner that we use to name that plane. Okay. Let's continue with some more of our definition and vocabulary for our basic understanding of geometry. Collinear are points that lie on the same line. Okay, you should see co meaning with or together and line in the word collinear. If they're not collinear, then we say they are non-collinear lines. Sorry, non-collinear points. And then we also have coplanar points. Coplanar points are points that lie on the same plane. If there are points that do not lie on the same plane, they are non-coplanar. You'll see plenty of examples of non-coplanar or collinear or non-collinear points on our GeoGebra activity that we're going to be working through in our next Zoom meeting. Okay. All right, I'd like you guys to try a couple of these examples where you're naming lines, naming planes, and identifying some points from each figure. So in example 1, you're going to name 3 lines. Example 2, you're going to name this plane in more than one way. And example 3, you're going to use this figure to name each of the following. Okay, continuing on to the back page, we have a few more definitions from our undefined terms using points, lines, and planes. So part of a line with 2 endpoints we call a segment. Part of a line with 2 endpoints and all the points between. Okay, in this example, there's no points in between. It's just our 2 endpoints, which would be AB, or we could name this BA. Make sure for a segment, and once again, a segment could be, you could name a segment if it's a line that has 2 ends. You're naming that segment when you use the symbol of just a line without the 2 arrows on each end. Okay, so you can still have arrows and be naming a segment. You would just need to make sure you don't have the arrows above those 2 letters. An endpoint is a point at the end of a segment or array. At the end of a segment or array. Okay, C and D, those are 2 endpoints of. This would be a segment because a segment has 2 endpoints, 1 and 2. You might be able to guess what array is. Array has 1 endpoint. So part of a line with 1 endpoint. And extends in one direction without end. Okay, just be really careful when you're naming array. The array needs to be named, well, we definitely need the symbol of array, which is just an arrow pointing in one direction. But when you're naming array, you need to make sure that the endpoint comes first. Okay, so R is an endpoint on both of these rays because it doesn't have an arrow after that. It's the part of a line where it stops. So when we're naming these 2 rays, we would name them the same, RS. Even though the direction is a different direction, we start with the endpoint first. An opposite ray is 2 rays that have a common endpoint and forms a straight line. Okay. Once again, make sure when you're naming opposite rays, you need the endpoint to be first. So the endpoint here, the common endpoint would be E. So the pair of opposite rays would be EG and EF. And we're always going to have the arrow going to the right. I know we have the arrow going to the left in this diagram. That's okay. And when we're naming rays, we'll always have the symbol above going to the right. Okay. Let's practice these together for example 4. You guys can go ahead and try this on your own if you want to pause the video. But let's draw a segment with endpoints U, V. So there's our line. There's 2 endpoints, U, V. If we were to name that, that would be U, V with our segment symbol above. Opposite rays with common endpoint Q. Well, we need that common endpoint Q. We need a ray going in one direction, which means we need another point on this line. We can just use A, that's fine. And another ray going in opposite directions, forming a straight line. That's not the best line. Let's try to make this as straight as we can. QA and QR. That's still not perfectly straight. Let's try again. There we go. R. So that would be QA and QR. Great. In example 5, why don't you try to use this figure and name some of the following that you might be able to identify. On our last page, postulates are similar to vocabulary terms, but because we're using points, lines, and planes to describe these properties, we just assume that these statements are true without proof. So they're statements that we assume to be true. In geometry, you're going to see that we prove every definition, we prove every term. For postulates, we can assume these are true without proving them. So this first postulate, we can assume that through any 2 points there lies exactly 1 line. 2 points, there lies exactly 1 line. For postulate 2, we can assume that through any 3 non-collinear points there is exactly 1 plane. That would be plane ABC. 3 points. There is exactly let's fix that really quick. Through any 3 non-collinear points. Remember, non-collinear points that do not lie on the same line, like points A, B, and C here. They aren't collinear. They're not lying on the same line. Through any 3 non-collinear points, there lies exactly 1 plane. Postulate 3, we can assume that if 2 points lie on a plane, then the line containing those points is on the plane. 2 points lie on a plane, then the line containing those 2 points is also lying on the plane. Okay, and that's what you see here. 2 points with a line extending through those 2 points. Those 2 points are on the plane. Therefore, the line is also on the plane. Postulate 4, if 2 lines are intersecting, they intersect at exactly 1 point. They intersect at exactly 1 point. And last postulate is postulate 5. Here we have two planes intersecting, and two planes intersect at exactly one line. They intersect at exactly one line. Great, we have an example here. Example 6 has a diagram of two planes intersecting. Why don't you go ahead and use this diagram to answer the following questions. Okay, well done. That's a basic understanding of some of our terms that we're going to use for this first unit. We're going to continue to practice them and illustrate some of them in GeoGebra. If you have questions, I can answer them on our Zoom call, and feel free to start the homework quiz when you would like.